And we didn't have to graph that. If you didn't see those x-intercepts, you could possibly, hopefully you were able to eliminate some of these answer choices and you could plug in a couple of numbers. But you would have to know exactly where it crosses, like right there. All right. So some limit stuff. Given the piecewise function above, evaluate the following statements. Write D and E if the limit does not exist. And so first off, we have the limit of f of x as x approaches -1. And so I just want to refresh your memory. For the limit to exist, so the limit of f of x as x approaches c, for this to exist, the limit of f of x, we have to have the limit as x approaches c from the left, and that limit has to be the same as the limit of f of x as x approaches c from the right. So for the limit to exist, the limit coming from the left-hand side and the right-hand side has to be the same. So let's take a look at x equals negative, the limit as x goes to -1. So as we go to -1, from the left, it goes to 1. As we go to -1 from the right, it goes to -1. So because the limit is not the same, the limit does not exist. Taking a look at the second one, the limit of f of x as x approaches 0. So as x approaches 0 from the left, and as x approaches 0 from the right, that limit would be -2 because that's what it goes to. And the limit of f of x as x approaches +1. So as we approach +1 from the left, it goes to -1. And as we approach +1 from the right, it also goes to -1. So that is our limit, -1. F of 1, we're just evaluating the function at 1. So we plug in 1 for x and we get out a 1 for our output. So f of 1 is 1. The limit of f of x as x approaches 2. Well, as we approach 2 from the left, we go to -infinity. And as we approach 2 from the right, we go to +infinity. So this limit does not exist. Question number 6, use your analytical skills to evaluate the limit. So the limit as x goes to 3 of this function. And the first thing that we would do with these is we would just plug in 3 and see if it evaluates. So the limit as x approaches 3 of 2 times 3 squared plus 3 times 3 minus 9, make that look more like that, over 3 squared plus 3 minus 6. So here, 2 times 3 squared. 3 squared is 9, and so 2 times 9 would be 18, and that's going to be plus 3 times 3 is 9, minus 9, and that's over 3 squared is 9, plus 3 minus 6. And so on the top, 18 plus 9 minus 9 is 18, and 9 plus 3 minus 6 is 6. 18 divided by 6 is 3. So we are left with 3. Now, if we were left with, say, a different problem, if we were left with an indeterminate form like 0 over 0, which we know we can't do, we'd have to do some more work and do some investigating. So I think this is the last problem. It is. So we're going to use our analytical skills to evaluate the limit of as x approaches 0 of this function. So again, the first thing that we would do is we would just plug in 0. And I'm going to kind of do that over here and just see what happens. So if we plug in 0 for x, this part simplifies to negative 1/3 plus 1/3 over 0, which would be negative 1/3 plus 1/3 is 0 over 0. And so that's not going to work. So we're going to have to use some algebra and figure out what's going on here. So looking at the top, we need to get a common denominator. And I'm going to rewrite the problem here, and I'm going to give myself some room. I like to turn this single x right here, I like to turn it into a fraction right now. It just helps keep me organized. Sometimes I get into the problem a little bit later and I've got a fraction on top and I just kind of forget how my fractions are separated. And that's just a note-keeping thing for me. So looking at our fractions up here, this fraction is missing in the denominator in x minus 3 and in x minus 3. So that's what we're multiplying this one by. On the other side, whoops, we are missing a 3. So we're multiplying the top and the bottom by 3. So multiply through. We know we have a common denominator. So just on the top, we can write this fraction as 3 times x minus 3. You could distribute the 3. It doesn't really matter. I'm not going to distribute it right now. Just see how this works out. So on the top, 3 times 1 is 3. And that's a plus. This is nice. We don't have to worry about distributing a negative. We get 1 times x minus 3 is just x minus 3. And this is, of course, over our x over 1. So let's clean this up a little bit. On the top, we have 3 plus x minus 3. My 3's cancel, and we're left with x over 3 times x minus 3 over x over 1. So we can't divide fractions. We have to multiply by the reciprocal. And so I'm multiplying by 1 over x. And so x over 1 times x over 1 is just 1. And we've managed to get rid of our fraction there. Looking at the top, on the diagonals, our x reduces. And so we're left with the limit as x approaches 0. Do not forget that you have this 1 here. It's 1 divided by 3 times x minus 3. So now we're ready to substitute our 0 in and just evaluate this function. So this becomes 1 over. If we plug in 0 for x, we get 0 minus 3 is negative 3. 3 times negative 3 is negative 9. So the limit is negative 1/9. Okay, so I want to point something out because this is fill in the blank. You have to be careful. They already have a negative sign there, so we don't need to worry about our negative sign. We know that A is 1 and B is 9. And I think that is it. I hope you guys found this helpful, and I will see you on the next problem set.